All right, let me see if I've got some sound here. I think I do. And yep, got some sound. So this is a pre-recorded lecture time or screencast for BISS 4403. I have to do some medical running around and on Tuesday then. So I'm just simply going to be out of pocket to get back to everybody by the time I need to for 12:30. So I'm going to record this and post it over in the announcements. Now, we're going to work on lunches database number 13, okay? And lunches database 13. You see, we're working through these deals with inner joins. So, you know, we've worked on, as I spoke about Thursday, okay, we've worked with inner joins, okay, pardon me, we've worked with row functions, we've worked with column functions, we talked about the analytical cube, where that all fits into this and how we can use row and column functions to give us multidimensional looks at our data, okay? And again, we can do those, we can do the drill down. And so now we're at the stage where and as I said, that ability to work at that level is what makes databases so powerful. And that's other than the solver function, other than the solver add-in in Excel, the pivot table is the most powerful tool that you have over there. Well, that all being said, we're going to look at chapter 13, and now we've gone from summarizing data, and if you have your book, you know, and you should each time, go to the table of contents, and you'll see where we've been. We've gone from, you know, saving results, data dictionaries, formats, sequences, data integrity, to row functions, and then summarizing data, controlling the level of summarization using groups. And now we're in chapter 13, 14, and 15, and 16, and we talk about joins and unions. And so now we're building up to chapters 13 through 16 build us up to the point at 17 where we create a production database, okay? And that's where we're headed to. And we'll see what that's all about as we get there, because that's kind of a new term that I've introduced into everything. Well, we're on chapter 13, and it's inner joins, and that starts over on page 473, so you'll want to go over there, okay? Now, technically, page 472 is 473 is inner joins. It gives us a nice flow of where we are, okay? Now we're going to talk about combining tables. And this is where it starts to get powerful, because when I can combine tables, as I've said before, I just enhance the law of the law of large numbers. And when I can do that, I'm really starting to get ahead of the game. So we're now in that situation where we're going to really start to see the value of data warehouses, production tables, and production databases, fact tables. When we begin to connect tables, right? All of this, our analyses jump almost exponentially. Now, over on page 474, he talks about the types of joins, variations of the join condition, and applications of them. And he talks about how we can, the different types of joins. So we're going to do this. You'll go back and you're going to get an old familiar friend, and that is the Patrick materials. Okay. And I'm going to open up Patrick. And I'll take an SQL file and throw it out there on the desktop. That's my warehouse. And then I'm going to open up the zip file that has the access, the code for the chapters. And I'm going to come down and I'm going to get chapter 13. I'm going to throw it out here on the desktop. Okay. Now, here's the code. And let's open it up. Okay. Oh, we got this stuff to contend with. And now I'm going to grab the code and we'll open it up as well. And this is the code for chapter 13. All right. Now, on 13.1, the authors talk about a query that can use data from several tables. Now, to really get the gist of this, you need to have the book with you. And I've been trying to get VitalSource to let me get this book on the bookshelf so you can see it, because I suspect many of you, even as you listen to this, don't have your book in front of you. And that's unfortunate because you're missing about 50% of everything. But I can't make it. You're young men and women. You're going to do what you're going to do. All right. You are now in the process of sorting and filtering your cells. I don't have to give you tests to determine who's going to be successful. I can look at other things and pretty much see who's going to excel, who's going to do very well, or based on high probabilities of that happening. Some of you will fool me. You won't do as well out there as I thought you would, and some of you will do far beyond what I would have expected you to do. I have expectations for all of you to run a company, own a company, okay, or be a principal player in some company somewhere or organization. All right? So, that being said, let's take a look at page 476, and you're going to see that we have 4 tables here. And so for the first step, all right, we have a query that draws data from several tables. And the second step then is that we get a result table. Now, let's look at this 13, and we're going to look at 13.3. Now, he talks about combining 2 tables at a time over on 476. And watch what he does. He starts with table A and B, and he creates table AB. Then he integrates table AB with table C, so he gets ABC. All right. Then he takes table ABC and he integrates it with table D, and you end up with table ABCD, and then the result table. Again, the law of large numbers. And he says, always do this 2 tables at a time. And I tend to agree with the author because it helps us keep straight what we're dealing with in terms of joins. Now, over on page 479, he talks about the types of one-on-one relationships, and he talks about column matching. And this is why primary keys and foreign keys are so important. The primary key in a table, of course, as you know, is the one that makes every record unique. A foreign key is a primary key that's embedded in another table, and it allows us to do some matching. And they talk about the one-to-one relationship between a couple of tables. And there on page 480, he shows us in that task in 13.3. Let's look at 13.3 for just a minute, okay? Now, again, I am so sorry about this having to be a pre-recorded session. You probably aren't. But I enjoy being with you. And but it's a visual. Well, it's a virtual Tuesday anyway. Why am I going through all this rigmarole? But I'm doing it. I'm not doing it live. Is the thing. I'm doing it pre-recorded. I have to make some medical appointments and then go over to a faculty meeting, and so it just destroys my day. But luckily, you don't have to come back and ask me what did I cover. It's there. Well, let's look at this, and we're going to see something very interesting. Select A dot fruit, B dot F underscore number, B dot C underscore number, B dot color. What's this all about? Well, what we're doing is, just like I can create an alias for a column, okay, I can create an alias for a table. And I have two tables that I'm working with here, tables A and B. Now, after I've said my select statement, I've got to declare what those tables are. And table A, as it tells me right here, okay, is the fruits table. Table B is the colors table. And we're going to join them where the number, the F underscore number in table A equals the color number in table B. And we're going to order it by fruit. Now, take a look for a moment, okay? And we have the beginning table, and this is over at the bottom, page 480. We see the beginning table, fruits. And they have a fruit, and then they have a column called F number, and that's the fruit number, of course. And we see each of those have a number. Then we have beginning table 2, and that's the colors table. And we have the color number, okay, and the color. And we want to match them where the AF number, and that beginning table A is on the left, equals, okay, the color number in table B. Now, the author has highlighted this for us by showing us a beginning table. We've got apples, bananas, cherries, grapes, and oranges. Over in beginning table number 2, we have a colors table, and the color number 1 is a red, 2 is yellow, 3 is red, 4 is purple, 5 is orange. And so we're going to look at the relationship between F number, F underscore number in the A table, and C underscore number in the B table. And we're going to order it by fruit. And here's our result. We have apples, okay? They're red, right? Correct. Banana, yellow, yep. Cherries are red, yep. And see the numbers for F number and C number, how they match up, okay? And what we did was the F number, the F number and the C number are probably the primary keys in each of their tables. I'm not quite sure. We'd have to go and take a look at that. That would be my hunch. And then we order them by fruit. So, you know, we can run this query, and that's what we'll get. And I'm just going to go ahead and let's just go ahead and run it. We're here. Click Control, and we'll go into SQL, our SQL fund, which we have open. And we'll do the usual shtick. We will click Create and Query Design, SQL, and I'm going to run the table. Now, we're dealing with fruits, okay, matching them on the color, on the fruit with the color. This could be cars. It could be, I don't know, shirts that we manufacture. Who knows? But the whole idea is that I use the two tables, and incidentally, let's just go ahead and change, save this as 13.3. Okay? And I want to go and look at those tables, and let's go look at the section 1303 fruits table. I'm just curious. Let's go find that one. It's section 1303 fruits. A little more to go here. A little bit more to go. There it is. Let's open it up for a minute. Let's go to the design. And, well, it's interesting. We don't have a primary key there. Well, it's a dimensions table, so I guess not. I'm surprised at that because I thought it did. Well, it doesn't. But that's okay because we have the fruit number and they have a color number. So that's okay. But we'll close this off. And the book illustrates very graphically how they match up. Okay? When you hear people talk about metadata, this is the exact type of thing. Color, in this instance, is metadata. Color indicates some fruit. Now, when you talk about the government wanting to listen in on everybody's phone conversations or get their phone records, when they talk about metadata, that could be any one of a number of things. It could be the area code. It could be an international phone number code to a certain country. It could be an area code in a specific exchange. That's all classified stuff that neither the phone company or the government's going to let us know, because if they do, then the bad guys figure it out. But that's all. When we're talking about metadata, it allows us to drill down and find these results. So we've created a join here between these tables, a match. Okay. Now, this is an inner join. And you say, what do you mean? Well, let's go back up to the database tools for just a moment and look at the relationships. And let's see if we can find 1303, section 1303. And, well, we've run a query. Well, I'll just show you over here. We've got this open anyway, all right? Let me see. Maybe I can find it. Let's look at the departments and the employees for a second. That'll make a lot more sense for us. Okay, let's just do this real quickly. And I'll take this and move it over here. Move it over here. In fact, let's get them in a good parent-child relationship, because these two tables relate on a one-to-many basis. Notice that we have a department code. Can more than one employee have a department code? Absolutely. So when we run this, we run an inner join. Okay. Now I'm going to click on here and the edit relationships, and it's going to say enforce referential integrity, one-to-many, using the department code, and then I'm going to click join type. When we talk about an inner join, this is the best way I know to show you. We could do it with that, or we could do it with Venn diagrams. And think of a Venn diagram where you've got set A and set B, and the place where they intersect, where they match up, where everything is exact, they match up. That's an inner join. Okay. Then we've got all records from the departments, and only those from the employees where they're joined. That's a left, and then we have a right join. And since I'm here and I'm fooling around with this, I'm going to close this off. Let me see if I can annotate something for us. And I'm going to try to draw something here. So this could be an unmitigated disaster. Lord only knows. And what do I want to do here? Okay. All right, I'm going to do this. All right. And then I'll draw another. All right. Now let me go back up here and stop the drawing. And let me see here. I want to use my little spotlight instead. This area right here, that's an inner join. This is where the two sets A and B match. Isn't that impressive? Now, a left join, I think you can follow me. I'm being funny and sarcastic here. I'm just teasing you. A left join means I get everything in set A, all right, and everything that matches with set B. In fact, I better go up here and I'm going to turn off my spotlight and I'm going to do a text thing. Let's see if I can do, and I'm going to turn this off, in fact. And then I'll go back here, this annotation. I'll do text. I'll make that A. This is set A. All right. I'll squinch this on down here. Okay. And then I'll do some more text, and this is set B. Those pesky Venn diagrams, right? And then right here, and I'm going to just, what I'd like to do is just go ahead and fill it in there, right? I'm going to close this off for a minute, and then I'll go back to annotate it. And let's see, I want to draw, well, and this is the one, well, oops, it's going crazy. I better erase these. Now, the little arrow in here shows me the inner join. This is where the elements match, okay? And that's all we're talking about. Now, in that case, the inner join is just simply a one-to-one relationship. That's all that it is. Now, let's pop over to page 483 in the textbook, okay? And I'm going to erase all this stuff here. But I thought you'd be very impressed. It's amazing, isn't it? All righty. Now we'll say that, and now we've got 13.3. And we're going to look at 13.4, where we have one-to-many relationships. Not one-to-many, like some of you probably do as you're dating multiple people, which is a dangerous thing to do, but one-to-many. All right? We're going down here to 13.4, and we can have a relationship of one-to-many. And that could be, for example, we have a many-to-one relationship. An example of that is a city, a city to a county, or a county to a state, or a state to a nation, or clients to a consulting firm. You have many to one. There are 50 states in the United States, but they make up one country. There's 77 counties in Oklahoma, but they make up one state. So we're talking about a many-to-one relationship. All right, so we're going to run this query. But before we do, let's talk about what we're looking at. Here we're going to select A fruit, A dot F number, B C underscore number, and B color from 1304 is the fruits table, that's A. Identify the B table as the colors table, where the number, F underscore number in A matches the C underscore number in B, and we're going to order it by fruit. Okay? And we're going to run that query and talk about what we're seeing once we run it. This will be 13.4, so I'm going to click create. And then I'm going to run the query. Now, a one-to-many relationship. Over on page 44, the authors show us the two beginning tables, the fruits table and the colors table. Now, again, we used a table alias, okay, when we did the A and the B. And that's a naming convention. It's a shorthand type of thing. Okay. Now we have the beginning table of the fruits, and then the beginning table of the colors. And we ran our query, and here's what we get. We get apples that are red. Okay. The color red has many apples, has more than one fruit. There's more than one fruit that's red. You know, we're talking about a many-to-one relationship. And here we're talking about bananas. They're yellow, but now, okay, here's red again. And purple, orange, and red. So we see that red has many types of fruits. The majority of these types of fruits in the table are red. Now you say, what good is this other than just running a stupid query and wasting my time? Here's what good it is. A many-to-one relationship, okay, lets me establish, okay, pardon me, a one-to-many relationship lets me establish that there's something that's a source, okay? And a many-to-one also tells us that there's some type of source, okay? And let's say that I'm looking at sales data, all right? And I continue to see a particular product bought by a whole bunch of my customers, okay? I have a many-to-one relationship, all right? Just as is depicted in number 4. So I have an N-to-one or a many-to-one relationship. And I have a product that I sell that many of my customers purchase. I have an employee who accounts for the highest percentage of sales. You can just work through the practical circumstances of it, however far you want to extend it. Okay, and you can see we're getting data from these tables as we start to look at how dimensions come into play. We know, for example, that the fruit here in our table, that the red is the prevalent color of fruit. We might find that the prevalent type of vehicle in the zip code is an SUV. We might find that the prevalent type of religious affiliation in a particular place is Catholic. When I lived up in St. Louis, that's Lutheran country. The evangelical, evangelical or the Reformed Lutheran Church, everybody's is a Lutheran or a Catholic, and then there's the rest of us. And it was really interesting because the Lutheran churches, that's Lutheran country, lots of Lutherans. I think you get the drift of the examples. Now in 13.5, they flip this around and say, let's talk about a one-to-many relationship. Let me give you some practical examples. This is a 1 to N. A mother with several children, an actor who plays several roles, a department that several employees are part of, a customer who accounts for a large number of our transactions. Okay? Each of these are designed to help us see or look for patterns. Now you start to see how database tools are so powerful because they allow us to look for patterns, not just select data and then throw them out there, not just select stuff and add it up and subtract it or summarize it or group it, but it lets us look for patterns. And when we see patterns in data, we're off to the races. Now I'm going to click Control C, and I am going very slow with these queries. I understand that, but I want you to see the business sense of them rather than just paste a bunch of them in like a monkey, okay? And here we go. I'm going to get rid of that, and we'll run that, and we're going to run it. There we go. This will be 13.5, so I'm going to save it as 13.5. Okay. Now let's know what's going on over on page 44, 485. They show us the code, okay, for a one-to-many relationship. And 46, they show us the beginning tables. And again, we're working with fruits and colors. A very simplistic, I understand, very simplistic. However, it helps us work through these, but the most important thing is that you can see here in a very concrete way how a database can help me look for patterns. Okay? The one example I gave you of a one-to-many was a customer who engages in a large number of transactions. Those are people you want to be nice to. You want to take care of them. Well, here we are. We got 13.5, right? And we've got a one-to-many, and we have the fruit number, all right, and a color number. And we see that apples can be red, apples can be green. We see bananas are yellow. We see that cherries can be red, grapes are purple, and oranges are orange. But we see here with the apple, it can be green or red. So we've seen a pattern where apples tend to be multicolored, whereas the other fruits here tend to have one color. This could be the same as I say, okay, I've got, rather than fruit, let's say I've got a certain color of shirt in a certain size, and this a certain color, I have a certain type of shirt. Let's say a polo shirt. And I sell them, I sell white ones, brown ones, blue ones, red ones. You get my drift. So I start looking for patterns. And this is just the beginning of how to do that. Then we have many-to-many relationships, all right? And that's going to be 13.6. Let's look at the code for it, and then we'll run it. And again, we're combining two tables. And we always identify the tables right here. So we're going to select the fruit. Okay. And then use the A dot. Then, so it's just shorthand. It's easier as we start to work through a couple of tables to just put A dot, okay, and then to identify what A is. So we'll copy this, all right? And then we're going to go into, and this is going to be 13.6. So I click create, query design, that whole bit, the SQL, and we're going to run it. All right. And here's 13.6. We have many-to-many relationships. I'll give you some examples of those. This is also, it's known as an end-to-end. Authors who've written several books. Orders to products. We have many orders and many products. Cars to vehicle ID numbers. We have many cars and they're related to many vehicle identification numbers. Again, as we start to work with the tables, you start to see we're looking for relationships. When we find relationships, we've taken that analytical cube and we've done more than just simply drilled down and gotten some data. We've basically worked through it diagonally, if you will, to find elements that are linear, or i.e. elements that seem to match up and flow together. If that makes any sense, think about it for a little bit and it will. And we're looking for patterns. Okay. And they show us the beginning tables over on page 4088 and then the result table. Okay. Now we have those situations where we just simply get rid of rows that are unmatched, and that's over in 13.7 over in page 490. Why would we want to do that? Well, there's no point in gumming up our report with stuff that we don't care about. So if things don't match, okay, if rows don't match up, we want them dropped. We want to get rid of them. So let's go here to 13.7. Okay. And I'm going to copy that. And then, and by the way, this will be 13.6. I'll just save it right now. Okay. And I'm going to work on 13.7. So I'll click create. Put in the code and we'll run it. Well, let me stop. No, let's run it and we get the results set. Okay. We've used an inner join to link the two tables, and we can see that there in the query over on page 490 or here in the text. And we want to get rid of any rows that do not have a matching row on the other side. Now they show you the beginning table for the fruits table and the beginning table for the colors table. All right. And note that we have cherry and grape, 3 and 4. We have over in the colors table, the color 6, color number 6, and the color is white. And so he tells us these rows don't have matching tables, so they disappear from the result set. They're gone. We get rid of them because they're redundant records. Okay. And we've done that where the AF number equals the BC number, and we've ordered it by fruit. Now, it's going to be 13.7. Okay. Now I'm going to run 13A. Now, if you take a look at 13.7 and 13.8 in your book, it's a little easier to compare them. In 13.7, we select A dot fruit, A dot fruit number, B dot C number, and B dot color. And then we get that from the fruits table and from the colors table, where A dot F underscore number equals B dot color number. And we order it by fruit. Okay. Now, again, what we're going to do is this time with 13.8, we're going to get rid of any row that has a null value. And you've heard me complain about null values, and they're the bane of all of us. And so let's click Create. Redesign. I will close this and we'll do SQL. And we'll run it. And there's our result set. Now, if you take a look over at page 492, you're going to see the beginning tables, then the result table. And by doing that, any rows that have a null in the matching column are dropped. Now, if you look over at page 492, we did this join, you'll see at the beginning, in the fruits table, we see that kiwi is null. Over in the color table, we see brown, it's a null value. So you will not see brown anywhere on the table, in the result table, okay? And you won't see kiwi as a fruit over here in the result table, and this is 13A. So the inner join also helps us just kind of get rid of some excess or additional excess rows, because we only want stuff that match. And if you look at them, the queries for 13.7 and 13.8 are exact. Okay? And we get rid of anything with a null, because if we have a null, they can't match up. So we just get the inner join just gives us that clean intersection of the two sets, i.e. in this case, the two tables. Okay? So we've looked for patterns. Now we've dropped out. We're starting to get rid of extraneous data. These are these in these beginning tables and the color, the fruit table and the color table at the top, page 492. When they have a null in a database, we consider that an outlier, because it just doesn't conform. We don't know what it is. It's the same if you ran a linear relation and you did a linear trend and you've got all these data clustering around the line best fit, and then suddenly you look and you got a data point way out there on its own. That's an outlier. Okay. So you can see now, over on page 493, the author talks about various ways to write the SQL for an inner join, okay? And he gives you the best way to do it, then a second variation, then a third variation, then a fourth variation, okay? And a fifth variation. And his explanation for each of these is over on page 493. So you'll want to look back there, okay? And in each of these, what you're doing is you're using an alias for the table. And at the best one, he says, just use a letter and then the field. Okay. And then the next one, he says, well, let's do a letter and then the dot and then everything. Okay. And then use the where statement and the order statement to call all that out. Then he shows you a third one where you fruit, where you instead of an A or B, you use a partial name of the table, and then you have the name of the column or the dimension. Then the whole name, this is down here in variation 4, and then 5. This one just is totally off the wall. He says it's fine for computers, not good for people. Okay, so and he says it's not recommended, and that makes tons and tons of sense. Okay, now as usual, he likes to show us that there are variations of this and variations for ways for us to do this, and so I'm going to skip 13.9 with all the variations. I don't think we're going to do that, but we're going to do 13.10 because it's a good one for us to take a look at. All right. And we're going to grab the code. All right. And what we're going to click create, and then the query design, we'll close it. I'll go to the SQL view, and we're going to run it. All right. Now let's talk about what we've got here. The select statement's pretty clear. I have 2 tables, and I'm pulling from multiple fields or columns. I know I have 2 tables because I've got an A and a B, and then when I come down to the from statement, okay, I identify what A is and identify what B is. Then I match them. I use an equivalence statement, okay, for A and B, and we order them by A.fruit. Now notice I've got the number for number 1 for each and a number 2 for each. All right. Now he's going to show us over by the bottom page of 496. He's going to show us the beginning tables, right? And so we can see the tables and those fields. And notice that over on the beginning table for fruits, I have a fruit number 1, a fruit number 2. And over on the colors table, I have color number 1, color number 2. And I get the result table at the top of 497. And let's look at that. Now, that's going to be 1310. You say, what's the big deal about this? Well, what we've done here, okay, is we've done a join, and now we use more than 1 matching column. We've used 2 matching columns. You say, what's the big point about that? As I said before, we use joins primarily to look for relationships or patterns. And the more that we can join and link up, the better our choice, the better the result set will be. Okay? And it's just simply, that's really all it boils down to is the law of large numbers. And you'll note here, I've got they all match up. I've got apples, bananas, cherries, grape, and orange. Okay. You can see now in 1311, 1311 walks through a range of values. Let me say this. You say, is it possible for me to use more than match on two columns? Certainly. You could match on as many columns as you want to, as long as you have the syntax correctly. Okay? And I'm not going to walk through the terrors of, here's one with 3, here's one with 4, 5, I'm not going to do it. You've seen it, and it works with 2. If it works with 2, it works with more than 2. And the more of them you get, the more precise the match you get. Okay? Now over on page 497, he talks about a join using the between, right? And I think you can take a look up at 498. It's 1311. And you can see the code. I'm not going to run it. I don't want to take the time. But here we are. And we know we have two tables. Why? Because I have an A dot and a B dot, and then I identify them. And then I use this powerful little function word, this very powerful little operation term, and it's between. So that's going to give me a range of their scores. And I want the test score between, everything between their A dot test score and their B dot beginning score and their B dot ending score. And I'm going to order it by student name. And watch what happens. Here's the beginning table, the ending table, and I get the student name, their test score, and their letter grade. And we've got their letter grade there in the ranges. So we're choosing a range using the between. 1311. 1312 is over on page 499. And I don't see any need to just run these, because folks, look, by this point, you ought to be able to see this. And if you've got the book in front of you, you can see the code, and you can see the beginning and ending tables, the beginning and the result table anyway. So here we're using a greater than condition. And as we look here, we've got what we're getting, everything from table A and everything from table B, because that's what the asterisk denotes there. And then we identify the tables. We come down, and we've got where everything in the larger number is greater than the smaller number, A dot larger number greater than B dot smaller number, and we order them by the larger number and by the smaller number. And you can see what we get. That's over in that's 1312. You can see the beginning tables, and we have the larger number, okay, and it's a word, and we have a smaller number, which is, and these are all this. We have numbers and words, okay, and he's doing this so you can see the potential of numbers and characters, combining them in an effective way, and we get the result table, and there's what we've got. Then using row functions, you say what? Yeah, the row function, page 501, if you look, you'll see where, and there's the plus operator. That's 13.3, 13.13. And a joint condition in the from clause. Now, that's over in 13.4, and he shows you the newer and older syntax of SQL and Oracle and Access SQL. And here we use the newer syntax, okay? We use the term inner join. So we do the select from, and then we say inner join. Then we invoke the inner join, and we identify the table where the inner join is to take place. And then we do it on, and that's the statement of equivalency, and then we order it. And he has the set of notes over there on page 503 that covers, that's 1314. He talks about applications of joins and everything. He talks about lookup tables. We've done those. He shows you those, combining a join and selecting data. A where clause, so we can perform two functions. He shows that over on page 508. Where the department code equals a department code and employee ID is less than 206, and then we order it. Okay? And he shows you each of those steps. And then we can do joins for summarization. And then he gets off into this business about the data dictionary and all that business in Oracle. Then 13.9 talks about combining 3 or more tables. And notice what's going on. If you look at the top of page 514, you're going to see it. Table A, Table B, Table D, and Table C. And you're getting most of the stuff out of A, it looks like, and some things out of B, C, and D, and you combine them and you get the result table. And what we get is employee ID, the first name and last name, the lunch date, the description, and the quantity. And that pretty much runs us through lunches database 13. Okay? So, I'm going to save this on my desktop. Okay? And, okay. And I'm going to put that SQL fun, and I'm going to put LD13. I'm going to put it up here on my desktop. I've got LD13. And I'll close it off. And now I've got, and I want to this is, here it is, LD13. I renamed it. And now I'm going to upload it. Let me go into the files. Okay. And we're looking at lunches, and I'm just going to upload it LD13 and open it on the desktop. There it is. Right? I just got it. And now I'll go over here to the modules, and I'll add it to the modules. Now, I really believe if you go and you take a look in the files, you're going to see some other files that cover 13. And as usual, all you really have to do is try, as it is for workshop credit. So I'm going to pop on this, and I'm going to do a file. I'm going to find, I might find an LD13 and just throw it up there. Well, here's a LD13 and 14 done. And I think I'll add that one up there. That's 13 and 14 done. All right. And I added one too many. I'll remove that. I'll publish that. And you got something there. And you also have what I loaded up here today. So I'm going to take this LD13 and 14 done. I'll move it up a little bit here. Okay. And then I'm going to show you one other thing, and then I'm going to call it a day. I'm going to select 13 and 14 done right here between. There's 13, 14, 13, 14 done, and then 15 upload here. One more time, okay? I want you to take a look at that. Here's a definition of a production database, because we're going to start talking about them, okay? And a production database is exactly what you think it means. It's one that does nothing but handles daily transactions. It's, for example, it would be close to a general journal for all intents and purposes. Okay, and we'll see how to combine tables to get one of those. Now, back over here for just a moment, and let me pop down here to where we was. And I want you to take a look again to refresh yourself about the difference between a database and a data warehouse. And then we have things called data marts, which are either highly specialized databases or just a small version of what we have in a data warehouse. And now we've gone to this concept of what we call data lakes, which means the data warehouse will have all the structured data, stuff that fits into a table very readily. The unstructured data is stuff that doesn't. We've talked about that. Things like followers on Twitter, comments in Facebook, reviews and stars on Amazon. Anything that just doesn't readily fit into a table, that's unstructured data. And we have to find ways to take that and clean it up and put it into a format that we can use in a table, and that's called data wrangling. Or we have to use some programming, like R programming, to take that data and put it into a format which we can understand. And R has a function called melt, where it just takes all the glump of data and says, okay, what do you want to call it? Which of these are columns? Okay. And so once you choose the columns, then the rows fall in place and away you go. That's for a course on R, which you can go take and enjoy. And then the OLAP, Online Analytical Processing, where we talked about that. The Data Cube, we've talked about that before. And some other things about databases that are just good practical examples of what's going on. Okay, well, I'm going to stop the share, and this will do it. This is our virtual Tuesday. I'm doing this in lieu of a live screencast. I'll explain to you why I've got to do that. And we don't meet on fall free days, so this will be it for you for the week. And be safe. Take care of yourselves, and I'll see you, I guess a week from this coming Thursday. That's when I'll see you again, because we'll have our ground-based session. All right, folks, take care.